Alright guys, welcome back to the channel. We're going to be solving question 5 from the chapter 7 of Hibbeler textbook, and we have these pliers that are used to grip the tube at B. We have a 20-pound force that is applied to the handles. We need to determine the internal shear force and moment at point C. We can assume the jaws of the pliers exert only normal forces to the tube. So the force that we are talking about is only applied normal to each of these jaws. So as always, we're going to start with the free body diagram, and we can just go with the free body diagram of one of these jaws. Let's go with the upper part. So I'm talking about this part of this plier. So as I mentioned, we only have normal force. We can show it with NB, and the other force that we have is the 20 pounds force that is applying on the handle. And let's just figure out the normal force in here. So we are in equilibrium. We have sum of all forces equals 0. And if we go with our moment equation about point A, counterclockwise positive as always, we have the moment of NB, which about point A is going to be in this direction. So counterclockwise moment NB times the vertical distance to the line of action. So we're talking about this distance, which is 0.5 plus 1 or 1.5 inches. And we also have the moment of the 20 pounds. This one about 8 is going to be clockwise, so minus 20 times the distance from A to the handle, or 10 equals 0. So here our NB, or the normal force from the tube to the jaw, would be 200 divided by 1.5. Let's calculate this. 200 divided by 1.5. That's going to be 133.3 pounds. And now we have to find the internal forces and bending moment at point C. So we're just going to do a section at C, and we're going to consider that section that I shaded in red. So we are talking about this part where we have our NB here, 133.3 pounds. And we can consider our forces in here. We are looking for our shear stress, and the bending moment, we're just going to call it MC. So this is our point C. And we can just consider one X and Y in here. We can call this one our X and this one our Y. Let's see what we get in X direction. So we are in equilibrium. Sum of all forces in X and Y equals 0. So here we can also consider an axial force too. We can show it with NC. But since there is no force in the X direction, if we do sum of all forces in X equals 0, the NC will be 0. But again, the question is not asking for that. We're going to do sum of all forces in Y direction equals 0. And we're going to have VC plus 133.3 equals 0. So our VC is actually in the opposite direction, minus 133.3 pounds, and this is the correct direction. So that's our shearing force. And if we want to find the moment, we're just going to do sum of all moments about point C. We're going to have the moment of 133, which is going to be in this direction. So it's counterclockwise 133 times the distance from point C to where the NB is applying. So it will be 1 inch. And we assume that our MC is also counterclockwise, so plus MC equals 0. And here we're going to get a negative sign that shows our bending moment is actually clockwise. And the unit will be pound inch. And it will be clockwise. So that's the final answer for this question. Hope everything was clear. Let me know if you guys have any questions, and you guys take care. I'll see you in the next one.